Are we good to start? Good?
Yes.
Are you guys having a good day? Good. Okay, so today we are going to learn about static electricity, or just electricity, but specifically static electricity, okay? It'll probably be a quick lesson today. Nothing too crazy, but as you guys know from what we learned in our introduction, electricity is very important in our world, especially in science and especially in STEAM. Electricity is like the foundation of how all of our technology works in our phones, in our computers. Okay, it's the foundation of how we transfer and how we transfer currents to produce power and create different types of machinery and further enhance different types of engineering. So here's the question, okay? What is electricity? Okay. So electricity is a form of energy made up of charges that can produce light, heat, or motion. So it's important to know what energy is when we talk about electricity, okay? Just like fire is a form of energy that produces heat, electricity is a form of energy that's made up of different currents, electrical currents, and different charges like positive and negative or neutral. Those are the three main charges that are within electricity. And when you have electricity, you can produce light, okay, from a light bulb. You can produce motion from a motor, okay? And there's also many other functions, but those are two important ones and very simple to understand that can be produced from electricity, okay? So here are the different kinds of electricity, okay? There's two main ones, okay? You have static electricity, which is an electric charge that collects or builds up on the surface of an object, okay? So we all have different charges that are, within our bodies and especially on the surface of our skin that can be picked up and that are static, okay? Later on we're going to do the experiment with the balloon, okay, where we rub it on our hair and we pick up electrons from the top of our heads and have an attraction with the paper. Hey!
Hi. Hi.
Hey guys!
Hi.
We have everyone. Good. Okay, good. Everyone's in the class. Good. Sorry I started a little bit later today. But this is everyone, right? We're good? We have everyone? Good. Okay. So, anyways, so there's two types of electricity. Like I was saying, you have static electricity and you have an electrical current. Okay? So static means that it's stationary and that it's an electric charge that builds up on the surface of an object. Okay, so I was giving an example of how we carry electrons on the surface of our bodies, especially on the top of our heads. We're going to do the experiment later and prove that. But when we walk around, if we're wearing different material like this, like a jacket, or if we're walking on a carpet, we can pick up electrons, which are small microparticles that have a negative charge, and we can pick those up from our feet that transfer throughout our body, and thus proving the fact that we carry and can carry an electric charge. We are positively charged as humans. We're not negatively charged, but we can carry electrons, like I said, on the outer surface that are loosely attached. So that's an example of static charge and static electricity. A current, an electrical current, is more of relating to circuitry and a power source. The simple example would be with a light bulb, where you have a battery and metal wires that connect to the light bulb and they turn on the light bulb, and there's a constant current, okay? A constant flow of electric particles, electrons that turn into neutrons, and there's a constant flow of those throughout that circuit that can power the light and continue it with the battery source. So there's the examples on the power lines, like outside, computers and different appliances in our house, like a stove or a microwave, whatever it may be. Even in our phones, there are electrical currents that stem from a battery or stem from a power source, whatever it may be, that produce a constant flow of charge, okay? But you don't really have to worry about that, and you don't have to worry about the current. We're going to be focusing on static electricity. The examples are like shocking, whenever you feel like have gotten shocked, or lightning in the sky. With the clouds, okay, that's also static electricity. So this is an example of electric current. You don't really need to know this, but you can see how you have the battery and then a light bulb, and then you can see the electrons circulating, going from negative to positive. It's a flow of negatively charged particles called electrons, and they call them charge carriers, okay? So you can see they go through on each end of the light bulb. There's a positive and negative end to the battery, all right? And they both shoot towards the battery through the metal current, which is a good conductor, the metal wiring, which is a good conductor, and it powers the light bulb to turn it on. And that's just an example of a current, but we don't really have to worry about that. We're going to be talking about static electricity, okay? So what is static electricity? The definition here, okay, we're going to read it. Friction can cause electrons to be transferred from one object to another, okay? The resulting imbalance in static electric charges can build up on an object and be discharged quickly or slowly. So basically, friction, which is like this, that's friction, okay? Whenever there's two objects, exactly, you got it. Yep. You can see there's heat building up, right? And your hands start to get hot. That's friction, okay? So we're going to do the balloon experiment later, and you can see how when friction happens, all right, it can be when we're walking, going down like a slide, whatever it may be. Different examples of friction, like I just said, whatever it may be, that can cause electrons to be transferred from one object to another. So for example, if we are walking on carpet, we're going to be picking up from our socks, okay, from the bottom of our feet, we're going to be picking up electrons from the floor when we walk, okay? And that's friction on the floor. So we can pick up negatively charged particles that way. And this, like it says, the resulting imbalance is, it's going to be built up, and there can be discharges, whenever you feel like zapped or whatever it may be. On the bigger scale, it can be like with lightning. There can be discharge slowly or rapidly. If it's on a big scale, like with the clouds, okay, you're gonna have big lightning strikes, and you're gonna see that in a second. So this is describing the two kinds of charges, okay? There's a picture to the right. It has a ruler, okay? Not a pencil, but it's a ruler. It's the one that measures, right? So there's a ruler, and after it's rubbed like this, friction can be on your hair, whatever it is, it can pick up negatively charged particles and attract the paper and attract the scraps, whatever it is, and you can see that the negative and the positive attract with each other. And we're going to actually learn about that in a minute, because that's also something very important to know when we talk about static electricity, because you have to know the different charges and if they attract each other or if they separate. Okay, so let's read at the bottom. Okay, it says a ruler carries an electric charge. Okay, an electric charge. It exerts electrical force on paper. So just like how it's showing in the picture, the paper's being attracted to the ruler after it's been rubbed through friction, gathering the negatively charged particles from the surface of whatever it may be. After that, there's electrons on the end of it that pick up the positively charged pieces of paper. This charging method is friction, like we said before. And the interaction between static electric charges is called electrostatics. So that's just the name of it, the science name, if you want to say. And that's basically it. It's very simple concept. This is one example with the ruler and the paper. I think there's going to be a chart here coming up that's going to show different types of objects that have a positive charge and different types of objects that have a negative charge, and how they are attracted to one another. So this is very important to understand. Okay, each of those little circles right there, the circles are representing the electrically charged particles, like the atoms, the micro level, the microscopic level. We can't see these, but they're representing those electrically charged particles. So the minus, okay, the dash, and then the positive. So you have the negative and then the positive. Okay? So negative and then positive. Just like on the screen. So the blue, the one in blue or purple, whichever one, that's negative. The orange is positive. And you can see when you have a positive and then a negative, they actually attract each other. Okay? Opposites always attract in nature. Okay? Especially when we're talking about electricity and static electricity and how different things attract. Okay, so positive and negative, they're going to attract. If you have a positive and a positive, they're going to separate. Okay, so two positively charged particles, okay, positive and positive, they can never come together. They're going to separate. And the same thing is with two negatively charged particles. So if you have two negatives, they have to separate at the bottom. It's the last one. You can see they have to repel. Okay? If you have a positive and a negative, they can attract. And that example is going to be described later with the experiment that we're going to do. Okay? So this is important, right? Electronegativity. These are the different objects. Okay, glass, we have hair, right? Hair, nylon, which is like plastic, silk, fur, aluminum, paper, cotton, copper, which is a metal, rubber, PVC, Teflon. Okay, so keep in mind with those for a second. Let's read this right here. Let's see what it says. Relative electronegativity ranking. This is the relative electronegativity ranking for some common materials, from electron donating materials to electron accepting materials. Okay, so this is not so much explaining their charge, but it's explaining if it donates electrons or it accepts electrons, which is important. Because the objects that accept the electrons, like Teflon, PVC, rubber, okay, the ones that accept the electrons are going to be used to show the attraction when you put positively charged like particles. It can be paper, whatever, dust, and you can hover it and show the static electricity and how the forces attract. The electron donating materials are the ones that don't accept the electron, but they give it, okay? And it's going to make sense when we do the experiment. I know you guys have your balloon, but we're going to do that in a second, not right now. But let's look at what we have. So glass, okay? Hair, okay? Glass and hair, those are the electron donors. They donate and they give the electron to the balloon or to whatever material it is. So when we do the experiment, the electrons from our head are going onto the balloon, onto the surface, and you're going to hover them over and they're going to show the attraction. Okay, so look at the top. We have glass, human hair, nylon, silk, fur, and then aluminum's right in the middle. Those are the ones that give. The ones that accept and that take the electrons, not give, they take the electrons from whatever material it is, are Teflon, PVC, rubber, cotton, copper, and paper. Okay, so they take the electrons. All right, where do charges come from? So this is kind of the one statement that you really want to have memorized when we're talking about static electricity, because like the theory of, I forgot the name of it. There's a name of the theory, but matter cannot be created or destroyed, okay? And this has to go with charges as well. Rubbing materials does not create electric charges, okay? You can't create electric charges. It just transfers the electrons from one material to the other. So when static electricity occurs, remember, through friction, right? Friction. When static electricity occurs with whatever objects and materials are around, the electrons, the negatively charged particles, the ones that are being moved, because remember, it's only with electrons, not with protons. Only with the negatively charged particles can we move them around. The positively charged stay on the person or the object, whatever it is. So when friction happens, the charges are not created. They don't magically appear, but they're transferred. So the electrons go from one person to the other, or one material to the other. So just keep that in mind when we're talking about static electricity. Okay. So where do charges come from? Okay, this is important too. When a balloon, right, rubs a piece of wool through friction, okay? So I have this jacket here, right? And this balloon. When the balloon rubs on the jacket or the wool, whatever it is, electrons, see the picture, electrons are pulled from the jacket. Electrons are pulled from the jacket to the balloon, okay? So it's this transferring to this, and it's all on the surface. Remember, it's static, it's not a current. The balloon has more electrons now than usual. So the balloon, negatively charged, and the wool or the jacket that's positively charged transfer, and the electrons from each go to the balloon because this, remember, it accepts electrons. The positively charged one cannot, and the opposites attract, okay? I have a short video that we're gonna watch, okay? So after this video, I have to make a new meeting link and send you the new meeting because I only have 10 minutes left, okay? So whoever, Anna, maybe afterwards, okay? But we're gonna watch this video first. Sorry. So see this picture here? The one to the left, the blue, the one in blue, that's the negatively charged particle, the electron. It's the negative particle. The one in the center, the one in red, that's a proton. That's a positively charged particle. And the one to the right is a neutron. It has no charge. Okay, so remember these three. All right, good. So look, make a pile. See my desk? Good. Put it in your hand like this. Here's what we're gonna do. Take your balloon.
Okay.
Take your balloon. Rub it on your head.
Yeah. Kinakain ko dapat yung balon. Agay!
You have to do it a lot. Like this. Yeah. Look, put it on your hair. Put it on your hair. Like him. Yes. The red shirt. Red shirt. Good job. Okay, keep going. Good, good. Like this. See? On the side. It has to touch your hair. Back, forth. Friction, okay? Okay? Now watch. See the pieces attracting to it? You see that? Look. Get the paper in your hand, okay? Paper in your hand. On your head like this. Watch what happens. Look. See, look, watch.
Hello. Init-init.
See, the paper is attracted to
Ikaw,
it.
ikaw. Ay, anak yung mayo, anak mayo.
You see? Is it working?
Yes. Yes.
Good, good.
It's working.
It's working, right? You have to press it hard on your head. Friction. You can pick up the paper. Okay? You guys learned something good today? Good. Good. Thank you guys. I'm very, very happy to have you guys. Be safe, okay? All right. I want to meet you guys one day. Hopefully, I can take a trip there and say hi. Be safe, okay? Thank you guys. Have a good day. Bye-bye. Take care. Thank you guys.
Bye.
Bye-bye.